Let's load up the heart disease data set. I think this is a great candidate data set to try KNeighbours on. The reason why is because if you're wondering whether a particular patient has a heart disease or not, it makes sense that, if you find patients who have, say, similar cholesterol and chest pain and other categories, that they would likely share whether the majority of those patients have heart diseases or not. Okay, so go ahead and open up this link and then save a copy in Drive. And what we're going to do is we are going to split the data set into training and a test set. And then we'll go ahead and run the code. And then we are going to try KNeighbours. Okay, so let's split the data. And so from sklearn.model selection, you just will eventually remember perhaps model selection, get used to it. There's some other things in there that are useful. Import train test split. And there it is. And then we need to take always X first, train followed by test. And once you know that, the rest falls into place. So it's X train X test, Y train Y test equals train test split on X and Y. Go ahead and run that code to split your data. Next, what we need to do is establish a KNeighbours. So let me try to help you find things when you're not sure. So you're like, well, we've been doing it like this from what? We're always using sklearn. Okay, that's our big machine learning library. And then we're usually using dots, which is like specific, kind of libraries within the library. Well, this is KNeighbours, and so you might think, well, is it in a neighbor library? There's neighbors. Yes, it is there. So choose neighbors. And then we're going to import what? Well, we've been calling it KNeighbours. So just type in a K. You can wait for it. Sometimes Colab is faster, so it's slower at actually providing you with some options. But it's K, and there with the N, it's showing me KNeighbours. And we want classifier because this is whether someone has a heart disease or not. The target column is 0 or 1 only. It is a classifier. And now let's do the regular steps. So it's model equals KNeighborsClassifier, and see the neighbors inside. You can go ahead and use that. It's going to be nice to just sometimes start with the default and see 5. Then we can do model.fitted on X comma Y. Wait, sorry. We're beyond that at this point. X train, Y train. And then we want to score it on the test set. And recall the reason why we scored on a separate set is because we want to know how it generalizes well to new data. It's not about curve fitting. This is about predictions in the real world. Okay, let's run the code and see what we get. Okay, so not the best score. 50% is sort of like point meaningless, right? Because it means you're guessing. So this is 65.7% accurate. We can try to loop through the different neighbors. So let's make a loop again. That's kind of fun. For I in range, let's do the 1 to 13 again. And then we can set model equal to the KNeighborsClassifier. Importantly, within neighbors, set to I because that's what we're iterating over. And then we can just both cases fit it on our training set and score it on our test set. I will also say that sometimes it's nice not to copy and paste because when you get used to writing these things, you start to learn them better. Okay, so let's see what we get. This is a very small data set, so we can do it all. Okay, I should have printed them out. Okay, let's print out the score as follows. So first, we're going to get it. Now let's do an F string. And so we're going to print. So for an F string, the idea is we want to keep track of the I. So I put the I in these squiggly brackets. And I mean, we could write I neighbors. We could make it a little more readable for us and give the score. And, you could say score. And then that's what is actually the score. Okay, try that again. And you can see, it's kind of interesting actually. So we get a peak here with 11. So we get this nice with 3, and then it drops and it goes back up again. So that's interesting. I think we could certainly up this, you know, maybe, you know, I mean, it's right. It's reasonable, right? Like, what are the closest 20 patients? And if you run this train test split again, it'll give you a different split. So this can also affect things. So I just ran a different split. Let's see what happens now. Yeah, we're getting like actually better scores with more neighbors, right? There's more variation. Now, something else that I would like to do here is actually normalize this data, because again, you go back to this idea of finding the sort of nearest neighbors. Well, hey, you're going to be close to like a lot of these values that don't have a lot of range, whereas like cholesterol, you know, it's got maybe too big of a range. So this normalized data set up here, I'm going to copy it and put it in here again. And there's really nothing like normalizing data. It's often good. Okay, like sometimes even if the scores are a tad lower, like we saw before, you know, it doesn't mean that they're necessarily less accurate. Okay, so what do? We put in the code. I'm going to put it right underneath here, and we modify it accordingly. Again, we already have our data. We're going to put in X here in place of DF because we're just changing X. And let's just give it X and double check that X has in fact changed before we run it through train test split again. You can see here also where the order of the code really matters, because I'm putting it in for like right up top. So then when I run the code underneath, it's going to resplit using the new X. But first I check it. Okay, and you can see now the values are between 0 and 1. Okay, and so now we have like an equivalence with our Euclidean distances. Okay, so let's try it again. We're going to run everything again, normalize data. Look at that, much higher score. Let's run this again, and you can see we get much better scores. Nice. Like here looks like the top is maybe 6, right? We could also put these in a list and return the max of the list, which would be kind of a cool way to do it. Very cool. Let's try it again with another split. Okay, similar score here and similar score here. So, you know, the normalizing data is making a positive difference here. Here we're getting the best from like 3 and 4 neighbors. And what the heck, we'll do one last one. This one's not as strong, so maybe a little more challenging of a split, which you get sometimes. But you're still seeing, that's kind of interesting when you get 1 neighbor is like the peak. That's a little surprising, similar to 3. Okay, so we see a clear advantage here to scaling data. So I would recommend trying that when you're trying k-nearest neighbors. It's a great model to try. And, you know, you may have noticed an issue with like, okay, like why should it matter so much on the split? And we are going to address that in full in the next series of videos.